Welcome to the deep dive. Today, we're going to be tackling massive scale data storage.
Oh, wow.
The systems that are handling just an unbelievable amount of data,
Yeah.
350 trillion objects.
That's really something.
That's like every photo, video, and document you can imagine.
It really puts things in perspective when you think about it that way. It's not just the sheer volume that's impressive, though.
Right.
It's the reliability these systems need. We're talking about 11 nines of durability.
Okay, 11 nines. That sounds kind of like a marketing slogan more than a real thing.
Yeah.
How do they even measure something like that?
Well, it's not magic, but it's close. Essentially, it means they aim for 99.99999999999% uptime,
Wow.
which basically means your data is safer there than just about anywhere else. Achieving that, though, involves incredibly intricate engineering and redundancy at every level.
Yeah, I bet.
Think multiple backup systems that can rebuild data from just fragments.
Oh, wow.
Even geographically separate locations in case of a disaster.
So it's like a digital Fort Knox for your data?
Yeah, you could say that.
With layers upon layers of protection. Yeah. But how did these systems even come about? Did they just, magically appear one day ready to handle trillions of objects?
Not quite. It's been a fascinating journey of evolution. Imagine back in the early 2000s trying to predict how much storage the world would need.
Yeah.
Initially, these systems were designed with individual users in mind, expecting to store maybe gigabytes of data per person.
Gigabyte, that's like a drop in the bucket compared to what we use today.
Exactly. They quickly realized they'd underestimated demand
I bet.
by a huge E-margin. The need for storage just exploded as more and more of our lives moved online.
Right.
So between 2006 and 2010, they were constantly playing catch-up, scrambling to expand capacity and handle the ever-increasing traffic.
It sounds like a pretty chaotic time. How do they manage to keep up?
Well, they had to get incredibly creative and think outside the box. They started adopting what's called a proactive approach. Instead of waiting for problems to arise, they began using predictive scaling and threat modeling.
Okay, threat modeling. I get that anticipating problems is good, but how does that apply to something as technical as data storage?
It's actually super crucial. Imagine you're designing a fortress. Threat modeling is like trying to think like an attacker.
Okay.
Where are the weak points? What kind of attacks might they try?
Right.
In the context of data storage, you're considering things like hardware failures, software bugs, even natural disasters.
Uh-huh.
By anticipating these threats, you can design systems that are resilient and can withstand just about anything.
So it's like running simulations to find the breaking points before they actually happen in the real world.
Precisely. And when it comes to proactive scaling, it's like having a crystal ball for data storage.
Okay.
They started using AI and historical data to forecast demand months, even years in advance. That way they could build capacity before anyone even knew they needed it.
That sounds incredibly complex and makes you realize how much goes on behind the scenes of services we just kind of take for granted.
Absolutely. It's a testament to the ingenuity and dedication of the engineers behind these systems.
But let's be honest, all this talk about trillions of objects and 11 nines of durability can feel a bit abstract. How does all this actually work on like a practical level? It can't just be one giant computer storing everything, right?
You're absolutely right. These systems are incredibly intricate. Instead of one monolithic system, they're designed around what are called microservices. Imagine hundreds, even thousands of smaller programs, each with its own very specific job.
So it's like a massive interconnected network of smaller systems all working together in perfect harmony.
Exactly. Each microservice has a unique role to play, and they communicate with each other constantly to make sure everything runs smoothly. This approach makes the system incredibly flexible and scalable.
Okay, I'm starting to see the logic here. But I have to ask, with so many moving parts, how do they even begin to organize all this data? We're talking about 350 trillion objects.
That's where things get really interesting. Think of it like a library, but on an unimaginable scale.
Yeah.
You need a way to find the exact book you're looking for amidst millions of others. That's where the concept of indexing comes in.
So instead of having to search through every single object every time there's a sort of digital card catalog that tells the system where to find things.
Precisely. But managing an index for trillions of objects is a monumental task.
Right.
That's why these systems use incredibly clever techniques like key partitioning and lexicographic key distribution.
Okay, those are some pretty big words.
Yeah.
Break those down for me. What do those actually mean?
Imagine that library again. Key partitioning is like dividing the card catalog into separate sections.
Okay.
Maybe one for fiction, one for nonfiction, and so on. This prevents any one section from getting too large and overwhelming. Lexicographic key contribution is a bit more technical, but think of it like alphabetizing those catalog cards.
So instead of one giant unmanageable index, it's divided into smaller, more organized chunks.
Exactly. That way, when the system needs to find a specific object, it knows exactly which section of the index to look in. It's all about efficiency and speed at a massive scale.
This is fascinating. It makes you realize how much innovation goes on behind the scenes of something as seemingly simple as data storage.
Absolutely. And we've only just scratched the surface.
Yeah.
There are entire teams of engineers dedicated to optimizing these systems, making them faster, more efficient, and even more reliable.
Wow. So we've got our library organized, but where does the data actually live?
Huh?
It can't all be in one place, right?
You're exactly right. It's all about spreading the risk and maximizing availability. These systems rely on something called multi-AZ storage, which means distributing data across multiple availability zones.
Okay, so break that down for me. What's an availability zone? Does that just mean different parts of a data center?
It's a bit more than that. An availability zone is like a self-contained data center within a region.
Oh, okay.
Each AZ has its own power supply, cooling, and networking infrastructure. So even if one entire AZ goes down, the others can keep running.
So if there's a power outage in one AZ, my data is still safe in the other ones. That's reassuring. But how do they make sure the data is actually consistent across all these different locations?
That's where replication comes in. When you store data in a multi-AZ system, it's automatically copied to multiple AZs. And we're not just talking about simple backups here. They use sophisticated techniques like erasure coding to make the system incredibly resilient.
Erasure coding. Sounds a bit like something out of a spy movie.
It's actually quite ingenious. Imagine you have a valuable piece of information that you want to keep safe. Instead of storing it in one place, you break it down into fragments and distribute those fragments across different locations. Even if some of those fragments are lost or corrupted, you can still reconstruct the original information using the remaining ones.
So it's like having a puzzle where you can still see the whole picture, even if a few pieces are missing.
That's a great analogy. The erasure coding is incredibly effective for protecting data from hardware failures, data corruption, and even natural disasters. It's a core part of how those 11 nines of durability are achieved.
That makes sense. But all this replication and storage must take time. How do these systems manage to stay so fast, especially when you're dealing with massive files like videos or high-resolution images?
They use some very clever optimization techniques. One of the key ones is multi-part uploads.
Okay, walk me through that. What does it mean to upload something in multiple parts?
Think of it like this. If you were moving a giant pile of books from one library to another, you wouldn't try to carry them all at once, right?
Right.
You'd break them down into smaller boxes that are easier to manage and transport. That's essentially what multi-part uploading does. Large files are split into smaller chunks that can be uploaded simultaneously.
So it's like having a team of movers instead of just one person trying to carry everything at once.
Exactly. It speeds up the upload process significantly and makes the system more efficient.
I can see how that would be helpful, especially when you have lots of users uploading files at the same time.
What about downloading those files? Is there a similar trick for that? There is. It's called parallel downloading. Instead of downloading a large file in one big piece, it's broken down into smaller parts that are downloaded simultaneously.
So it's like having multiple download lanes instead of everyone trying to squeeze through one.
Precisely. It maximizes your bandwidth and gets you that file much faster.
Okay, I'm starting to grasp the complexity here. We've covered indexing multi-EZ storage replication, erasure coding, multi-part uploads, parallel downloads. It's a lot to take in.
It is.
But how do they make sure all that data is secure? Well, we'll have to dive into all that when we get back after the break.
We will.
Stay with us. Welcome back to the Deep Dive.
Wow.
Before the break, we were in the middle of talking about security for these massive data storage systems.
Right.
We were talking about how they are organized across multiple availability zones and all the different ways they keep the data safe. But when it comes to actually keeping the data secure from hackers and things like that,
Right.
how do they handle that?
Security is absolutely paramount in these systems. We're talking about multiple layers of protection.
Yeah.
It starts with access control, making sure that only authorized users can access specific data.
Yeah.
They use what are called IAM policies, which are like digital ID cards that define who can do what within the system.
Right.
And then there are bucket policies, which are rules that apply to entire containers of data.
So you can have a bucket policy that says all the data in this container has to be encrypted,
Right.
or that it can only be accessed from certain locations.
Exactly. It's all about layers of protection and making sure the right people have the right level of access.
Yeah.
And then we can't forget about things like encryption, both in transit and at rest, to protect data from prying eyes.
Right.
And then there are security measures to prevent things like DDoS attacks, which are basically attempts to overload a system with traffic and take it offline.
DDoS attacks. Those are like the digital equivalent of a mob trying to storm a castle.
That's a great analogy. These systems have sophisticated defenses in place to detect and deflect those attacks, keeping your data safe and accessible.
Wow. It's incredible how much thought goes into protecting data at this scale. But with all these complexities and challenges, is it even possible for regular organizations to build and manage these systems on their own?
It can be incredibly challenging, especially for organizations without dedicated IT expertise.
Right.
That's why many companies are turning to solutions providers like Stonefly.
Oh, hi.
Yeah, they offer a range of products and services that make it much easier to deploy, manage, and secure data storage systems, even at a massive scale.
Stonefly.
Yeah.
I'm sensing a theme here. It sounds like they've really positioned themselves as leaders in the data storage space.
They have. Their expertise and commitment to innovation are really impressive.
Yeah.
They've helped organizations across various industries implement robust and scalable data storage solutions that meet their unique needs.
So we've covered security, we've talked about performance, and we've touched upon the complexity of managing these systems. But there's still one piece of the puzzle that I'm really curious about: the evolution of data storage.
Right.
It's not like these massive systems just appeared overnight. How did we get from storing gigabytes on floppy disks to trillions of objects in the cloud?
That's a great question. The journey of data storage has been a fascinating one, and we'll delve into the key milestones and innovations that have brought us to where we are today.
It's amazing to think about how far we've come.
It is.
We'll be right back after a quick word from our sponsor. Welcome back to the Deep Dive. So before the break, we were talking about the evolution of data storage.
Right.
How we got from, floppy disks and things like that to the massive cloud systems we have today.
Yeah, it's been quite a journey. In the early days, data storage was primarily focused on individual users and small businesses. Think personal computers with hard drives that held maybe a few gigabytes of data.
A few gigabytes. That's like one high-resolution photo these days.
Exactly. But as the internet exploded in popularity, the need for storage just skyrocketed. Websites, applications, online services, they all started generating huge amounts of data.
Right.
And those old hard drives just couldn't keep up.
So what happened? How did the industry respond to this growing demand?
Well, a necessity is the mother of invention, right? We saw the emergence of network-attached storage, or NAS, which allowed multiple computers to share a central storage device.
Okay.
This was a big step forward, but it still had limitations in terms of scalability and performance.
So NAS was like having a shared library for a small group of people, but not quite ready for the whole town.
That's a great analogy.
Hmm.
And as the amount of data continued to grow, the industry started looking for even more scalable solutions. That's when storage area networks, or SANs, entered the picture.
Okay.
These were dedicated high-speed networks designed specifically for data storage.
So SANs were like building a superhighway specifically for data to travel on.
Exactly. They offered significantly faster speeds and greater capacity than NAS, but they were also more complex and expensive to implement.
It sounds like a constant game of leapfrog. Each new technology trying to keep up with the ever-increasing demand for storage.
That's exactly what it was. And then around the mid-2000s, we saw another seismic shift in the industry, the rise of cloud computing companies like, a lot of companies started building massive data centers and offering storage as a service.
Ah, the cloud. That's the magical place where all my photos and files seem to disappear to.
Yeah.
But seriously, what made cloud storage so revolutionary?
It changed everything. Suddenly, businesses and individuals didn't need to invest in expensive hardware or worry about managing complex storage infrastructure. They could simply pay for the storage they needed on demand and let the cloud provider handle all the technical details.
It's like renting an apartment instead of having to build your own house.
Yeah,
You get all the benefits without the hassle.
exactly. And the cloud offered something else that was game-changing: scalability. You could start small and easily scale your storage up or down as your needs changed. No more worrying about running out of space or having to invest in expensive upgrades.
It's amazing how quickly cloud storage became like the go-to solution for businesses of all sizes. But didn't this also create new challenges, especially around security and data privacy?
Absolutely. When you're entrusting your data to a third-party provider, you need to be confident that it's being protected. Cloud providers have invested heavily in security measures,
Right.
but it's still a major concern for many organizations.
It's like putting your valuables in a safe deposit box. You need to trust the bank. And speaking of trust, you mentioned a company earlier that's really made a name for itself in the data storage space, Stonefly. What makes them stand out?
Stonefly has been a leader in the data storage industry for years, and their focus on innovation and customer satisfaction is really impressive. They offer a wide range of solutions from traditional storage arrays to cloud-based storage platforms,
Yeah.
but what really sets them apart is their commitment to security and data protection.
So they're not just providing storage space, they're building Fort Knox level security around that data.
Exactly. They understand that data is one of the most valuable assets a company has, and they've gone above and beyond to implement robust security measures that give their customers peace of mind. They offer things like military-grade encryption, multi-factor authentication, and even tamper-proof audit trails.
It sounds like they've thought of everything.
Yeah.
But I'm curious, what does the future hold for data storage?
Right.
We're generating more data than ever before.
Hmm.
Where do we go from here?
That's the big question. One thing's for sure, the demand for storage is only going to continue to grow. We're seeing exciting new technologies emerging like NVMe storage, which offers blazing fast speeds,
Wow.
and edge computing, which brings data processing closer to the source. And companies like Stonefly are at the forefront of these advancements, constantly pushing the boundaries of what's possible.
It sounds like there are some amazing innovations on the horizon.
Yeah,
But for those of us who aren't like tech experts, it can be hard to keep up with all these changes.
yeah.
What advice would you give to businesses that are trying to navigate this complex world of data storage?
My advice would be to focus on your needs, not the technology. Start by understanding what you need to store, how much storage you need, and what level of performance and security is required. And then look for solutions that meet those specific requirements. Don't get bogged down in technical jargon or buzzwords. And don't be afraid to ask for help. There are experts out there, like the folks at Stonefly, who can guide you through the process and help you make the right choices for your business.
That's great advice.
Yeah.
It's a reminder that even in the world of technology, it's still about finding solutions that solve real problems for real people. And that brings us to the end of our deep dive into the world of data storage. We've covered a lot of ground today, from the nuts and bolts of how these systems work to the historical evolution that brought us to where we are today.
It's been a fascinating journey.
It has, and I think we can all agree that data storage is no longer just about storing files. It's about protecting information, enabling innovation, and ultimately empowering people to do amazing things. So the next time you upload a photo stream, a video, or access a file in the cloud, take a moment to appreciate the intricate systems that make it all possible. And remember, there's a whole world of innovation happening behind the scenes with companies like Stonefly leading the way. Thanks for joining us on the Deep Dive.